So I'm just going to run through how I would go about setting up a modifier stack for dealing with things like a car. So what I've got here is my base mesh, and in general it's okay, but to check if our surface is flowing nicely, we want to go to shading up here and then press matte cap. And there's a few here. I've got 3 more than normal. You're able to press this little setting icon and press install, and you're able to download some off the internet and just plop them in there. So these 2 are from Blender 2.7. I find them quite useful, and this last one is one I made. So the ones you want to use for doing something like a car is the metal car paint, this one here, the rim light here, and these 2 vertical and horizontal studio lights. So this is the rim light, and this one shows up every flaw in your mesh. So if I'm looking down here, I'm able to see that there's a dent here, there's a dent in there, there's dents pretty much all around with this, despite it being fairly smooth in general. So how do we fix that? Well, we can see that these aren't smooth, so we can do something like circle select the areas which aren't as smooth as they should be, right click and go to smooth vertice, and it's a bit like a relax, and it starts to smooth those vertices over. Just bear in mind, the more you smooth, the bigger the difference is going to be from areas you're not smoothing. So use that one carefully. There's of course the normal slide vertice. Another really good one is the smooth Laplacian. I'm not entirely sure how you say it. This one, and this tries to smooth without losing any angles, so sharp angles that you make. And that's quite a good one to use also. In general, it's a lot of sliding and keeping everything nice and tidy. There's of course the loop tools, which are an add-on which is in Blender by default. You find those by right-clicking loop tools. And there's relax and space. Be really careful. These only work on a loop. So say I'm dealing with this area here, and I want to make sure that's nice and smooth. Well, if I right click and go to relax, it tries to distribute them and relax the shape so they flow nicely. The other one is space, and that evenly distributes them along an edge, which is quite a useful one when you're building up a mesh. So this here, I don't want all those. So right click, relax. It will sort out any bumpiness in that sort of in that loop. So that's a couple of ways of dealing with the mesh itself. So that using this matte cap. Like I said, there's the other 3. So the studio light, a really nice one to use just to check the mesh. These 2 here, they're really hard to look at, but if you know what you're looking for, you can see any mistakes with it. So what I try and do is line up the car with the vertical one and see where there's any deforming. So there's none in the vertical. In the horizontal though, we can see just here, this area here is not working quite right. It's not flowing like the rest of them are. Another thing that is useful in viewport is the cavity maps. So here, cavity, turn that on, set type to both, and just crank these values all the way up to full. And sometimes if you've got an area which is a bit too bumpy, the highlight comes up. We can of course type in values we want. So really extreme sizes for those, and sometimes you're able to spot things which you're not normally able to spot. In this instance, it's not really showing us anything new. No. So how do we deal with this area? If we can of course go in here and start smoothing stuff up, we can also do it with modifiers. So at the moment, my modifier stack is really simple. It's just a mirror and it's a subdivision. I'm just going to hide the subdivision for a second, and I'm going to add a smooth lapletion. So there's a few smoothing options. There's smooth, just smooths your whole mesh. Smooth corrective, that's for anything that's for your mesh when you've got anything that is deforming. So you're using the splice or an armature, and your mesh is deforming in a way which it shouldn't quite. It sorts of fixes that. And smooth Laplacian, which will reduce noise. So if you add this, the reason I turned off subdivision is this is a very heavy modifier. It's really computationally heavy, and I want to put this above the subdivision. For the time being, it's a good idea to mess around with the order of these stacks while you're doing this. So what I'm going to do is turn on my subdivision again. In general, you want the border to be 0. You don't want any smoothing along a border, and you want a very low factor, because if it's too high, you start losing your actual shape, and we just increase this repeat value. So let's put this to 200. And we can see our mesh is looking smoother. So if we toggle it on and off, we can see our mesh is smoothing. But we are losing some volume. And of course we could reduce this even further. So we're losing less volume, but you'll notice that in this area here, and these areas here where we've got this curve there, which shouldn't be there. See that? We can see the effect of that is reduced. So that's working okay. It's smoothing some areas we don't want to smooth, though. So what we can do is add vertex groups. So in this case, it is probably worth weight painting. So we just go to weight painting. I'm going to turn off subdivision and smoothing, and just sort of paint the area which I think should be smoothed. So that area probably should be smoothed. I'll just turn off the matte cap. And there should be smoothed. Along there doesn't need to be. What you could also do, save some time, is go up here, press select, sharp edges, and then grow that selection by 1. So we've got the areas which are sharp, or some of the areas that are sharp, and just press remove from the vertex group. So we can see that some areas which are sharp, we don't want any smoothing on sharp areas. So we've just removed that area. So let's say that's the back of the car. I want the area of the back of the car to smooth. We should give it a name. And set the smoothing to have a vertex group of just that area. Now when we turn it on, only that area is going to be smoothed. So we can see there, it's being smoothed. And because we've only selected some areas, and we've not selected any area where there's anything too sharp, we can increase the factor a bit. Maybe not so much. So that's looking better. And if I turn on the horizontal lines, there's still a bit of a mark along here, but it's very minimal now. And in our car paint view, it's really hard to spot. Whereas if we turn it on, turn the smoothing off, it's a bit easier to spot. It's just there. Turn it on, it disappears. And you can keep going with this. So we've got, so this is smooth back window, and now we can just add another one, smooth, and pick out any other areas which should be smoothed. Just bear in mind, if you've got a subdivision surface and it's high, it's on a high setting. At the moment mine's on 3, so there's nearly 200,000 faces, which isn't that many really, but this operator is very intensive. When you add one, you should turn off your subdivision, add it and move it to the right space. What I've done is made the mistake of adding it with the subdivision still on, so it's going to take a second for it to pop in. There we go. And I'm just going to hide the subdivision. Now I can move it around. There we go. So we'll just select another area that it needs to be smoothed. So go to our matte cap. Where else needs to be smoothed? Maybe this area here. And I'm just going to assign the vertex group. Whoops. This way. So add vertex group. Go into weight paint. And I'm just going to smear this a little bit. It's worth turning off subdivision when you're working with weight paints. It's unnecessary to have the overhead processing. There we go. Turn this matte cap back on. And let's select side window smooth. Turn it on. Just increase the value a bit. And we can see how we can start smoothing up our model non-destructively. So we're still able to go into edit mode, see what it actually looks like, and work from that. And like before, if we turn on these show in edit mode, we can see exactly how our mesh is being deformed. So turn it on and off. So that's the base mesh, and of course you'd keep going with that. to build up a really smooth mesh. Another tip that might be worth doing is adding a material to the car. So add new, and we're just going to use the viewport shading, and we're just going to give it a full metal material and turn the roughness all the way off. And we can change the HDRI, and we can see how that looks with different HDRIs. So that's our base mesh, and to keep our scenes tidy, I'm just going to put this in a collection called Shrink. And in our main collection I'm going to add a new object to start retopologizing with. And of course I'm just going to add a mirror, and of course set our origin to be in the world origin. There we go. And now we're able to work. It may be worth also giving these objects different colours, and we can do that by going over here to Objects, Properties, going down to Viewport Display, changing the colour. So I'm going to give this one a yellow colour and give this one a slightly blue colour. And all we do is go up here, instead of it being on single, which lets us change all the colours, we go to either Object or Random. Object just gives you a little bit more control. And it just tints the matte caps. So the ones with an actual colour do look a bit weird, but you can see how how to separate up your models. So it's nice and easy to work with. So I'm just going to set up the modifier stack for shrink wrapping. So we have a mirror. Actually, let's shrink wrap and then mirror. Make sure we shrink wrap to that. Turn on cage so we can see what we're looking at, and make sure we're putting this in front so we can actually see what we're dealing with. And of course you'd retopologize if that's how you're working, and you'd keep going with that. What I've done here is sort of separate my model up already, so I'm able to separate out panels. So I just select them up and extract them. So if I do that, and the other option for doing this would be retopologizing. So I'd probably actually have to retopologize this, maybe. That this panel should actually be straight. So what I'm going to do is duplicate this, move this to our main panel, select everything except the door I've just selected, delete it, and give it a different colour. There. So now we've got this door panel and we can imagine this is a retopologized mesh. I'm just moving quickly. And so how do I set up this to be able to conform to this shape? Well, like before, we have our smoothing, and we can leave that, but what I'm actually going to do is apply those two, give our subdivision back, and add modifier shrink wrap, not deform, shrink wrap to that, and I'm just going to change it to target normal. target normal and nearest surface point are very similar. Target normal sometimes gives you slightly better results. Make sure your subdivision is at the bottom. And I think because we're going point to point in the edge, target normal's not working as well. So I'm just going to leave it on nearest surface point. And I just want to put that in front. I've added that to my quick favourites. So now I'm able to select those edges, and if I turn on snapping, set it to face and set it to not project onto self but project onto individual elements, and I'm going to do snap with active, which means when I select this point here, see it highlights, that's now my active selection. It's going to use that one to snap. There's really very little difference. You don't notice these options very often. Keep it on active or medium, you're less likely to fall into problems. Also, turn on rotate, so just shift click that one. And now I can just slide that along. And we're able to scale all these. If you want to scale them all individually, just select all the loops. Change this to individual origins, scale on the y-axis, press 0. Actually, I don't want that one, do I? There we go. And we can move these around, and it's all being shrink wrapped really nicely. We're keeping our original shape really well. So what if we want to add some depth to this? So let's say we're happy with this shape and we want to add depth to it. Well, normally you would have to do this destructively, so in Maya would have to be destructive, you'd have to select the edges, extrude in. But what we can do is work fully non-destructive with this, at least until the very last stage. And all we do is build a modifier stack. So what I'm going to do is just remove the subdivision, just so I can add it at the end. And what I'm going to do is add a solidify modifier. So if I press that, I'm just going to hide the shrink wrap layer. So we're looking at this. You see it adds depth. If we slide the thickness, we can see it's adding thickness to our mesh. There's a few options to know about this. There's two modes, there's simple and complex. In general, I keep it on simple. I turn it on to complex when simple isn't working the way I want it to. And there's a few options here. We want even thickness all the way around. We want high quality normals. We want to fill the rim. And in this case, unless you're needing this interior edge, we don't need that. So we can just turn on only rim, which means we're only going to be left with this flat side. Some other things to know: clamp. Sometimes if we make the thickness too large, we need to clamp it, so we're not getting overlapping edges, and you'd have to go in and fix this manually. Also angle clamp, two ways of dealing with it. The complex also has the same issue. But in general, we only need a thickness something like that, and that's not going to be an issue for us. So that looks good. So if we had a subdivision now, you'll notice that edge isn't beveled. And that's a problem, because we're working non-destructively. We can't just go into edit mode and add it. So we have to do this non-destructively too. And there's a robust way of doing this, and there's a less robust way of doing this. And it's bevel. We add a bevel modifier. That's a ray. Bevel. And we just want to set this to be on angle. Increase the profile to be 1. 2 segments. We look in wireframe, see what it looks like. We can increase the offset until it starts clipping. We can look to see where it's clipping. If we turn off clamp, where's it clipping? Ah, that'll be here. And we can adjust the angle. And now only those edges are beveling. So now if we add a subdivision, reduce the thickness, bevel offset, sorry, we can change how sharp it looks. And we've got a nice profile on our car door. However, like I said, this is a slightly less robust method. And the reason I say that is, say we have a shape like this. We have a car door. It's got an indent. So it's got an extrusion. Like that. We've still got shrink wrap on, so I'm just going to add a no shrink group. Assign it. Go to shrink wrap. No shrink, and invert it. We can see that this is also being beveled now. We don't really want that, because say we're doing some complex topology in here. If it's starting to bevel areas we don't want it to bevel, that's not ideal. Also remember to turn your outer mitre type to be arc. So we have this shape here, which is really easy just to, after we're happy with the shape, we just confirm all our modifiers and we just join point to point, and our topology stays nice and clean. If it's on sharp, it does that there, and that causes problems. So keep it on arc. So let's, in this example, I don't want this interior area to be beveled. For many reasons, could be the case, but I don't want it to be beveled. So how do we get it to bevel only this edge? Well, we can do that with some procedural vertex groups. And of course, Bevel's able to use a vertex group to control where the bevel is going to happen. So let's open up our Solidify modifier, and you'll see here there's 2 vertex groups. There's shell and there's rim. And what I like to do is, on all the models I make 2 vertex groups with the same names, rim and shell. I don't press assign to anything, I just leave them there. So in general, I set up most of my models to start off with these 3 vertex groups, no shrink, rim and shell, because I do this workflow quite a lot. And as the name suggests, we just drop shell and rim into these vertex groups. Nothing seems the same to change, so if we go into weight painting and select rim and shell, we can see that these are procedurally being assigned, and we can see what each one is. So that's what rim is, that's what shell is. If we turn off only rim, we can see this is what our shape looks like, and that is what rim looks like, and that's what shell looks like. So shell is the inside as well. In this case, we don't need that internal edge, so we don't need to deal with that. But I'll give an example where we do deal with having the inside filled as well, because it's just an extension to this workflow. So looking at these vertex groups, rim and shell, if we have rim and we subtracted shell, we would be left with only this edge. You see that? So this is red, and only this is marked as red. If we subtract them, we'll be left with this edge. So what we want to do is some vertex weight mixing. And these are on the Modify side. And I really rarely use this side. We use these mesh cache data transfer stuff when you're using Alembic files. And you can do some UV magic with that, and you can adjust normals with these modifiers. But in general, I really only use vertex weight mix. And it's a really simple node. It's a really simple modifier. We've got two vertex groups, A and B. We just add. We want to subtract shell from rim, so we put rim in here and shell here, and change the mix mode to be subtract. And now I'm looking at rim. I'm in weight paint mode. I'm looking at rim, and we can see that edge is the only edge marked, and so that's the edge we want to bevel. So all we need to do is make sure our weight mix is above the bevel modifier. I'm gonna. It's sometimes worth naming the modifiers. When you're getting a large stack like this, it's sometimes worth naming them. In general, this is fine for the moment. I'm just going to change this from angle. I'm in the bevel. I'm changing it from the limit from being angle to vertex group, and I'm going to set it to be rim. And now we can see only this edge is being beveled, and the area in here is not. And we're able to adjust the offset. And when we add a subdivision now, it is being dealt with properly. What you may notice is here though, this corner is not being beveled. And we can deal with this as a separate case. And what we do for that is add another bevel modifier. I'm going to rename this one to be bevel outside edge. I'm going to rename this one to be bevel corner edge. And all I'm going to do is literally select the vertices which I want to be kept sharp. So just those two. I'm going to make a vertex group called corners. Assign them as a weight of 1. And I'm just going to go to vertex groups, add corners, and give them the same size, like that. Make sure it's on arc. You'll notice we've got an end gone here, but this isn't a hard bit of topology to fix. Really, you could do something like this and deal with it that way. But you have to do that non-destructively. You have to do that destructively, sorry, once you're happy with the modifiers. So again, if we add the subdivision, that corner is now kept sharp. But at the moment the bevel is different. These two bevel offsets are different. A good way of keeping everything really clean and really easy to deal with is using something called drivers. And drivers simply copy values from one place to another. So if I right click on offset, our menu appears at the bottom here. There is copy as new driver. That's the only one we want. There's keyframing, we don't need those. We want copy as new driver. Nothing changes. We go to our now bevel corner edge. We right click on this, and up the top we press paste driver, and we see it highlights now. So if I get both of them up at the same time, as I slide one, the other one changes with the same value. What you can also do is say we want this bevel to be half this bevel. We can right click on this and press edit driver. This menu appears. It looks scary. It's not. for dealing with something like this, all we want to change is it from being averaged to being scripted, and all it does is let you use expressions like divided by 2. So really simple. So that's using drivers. We can also extend this, the drivers, I mean. So we have a car and there's lots of panels. It's worth having an empty object, just empty cube, and I'll make it quite small. And I'm just going to call this our driver controller. And all this is going to do is act as a storage point where we're going to put all our drivers. So if we select it and we go to our object properties icon, down at the bottom here there's something called custom properties. If we drop that down, there's just a button that says add. If we press it, a value appears. If we press edit, we're able to name it. So I'm going to name this car panel bevel offset. We're able to set min and max. I'm just going to use soft limits. Actually, never mind, I'm not going to use that. We're able to give it a tool to, so let's call it bevel width. And we see we've got a slider here. And what I'm going to do is give it a small value. And like before, I'm just going to right click, copy as new driver. Now I'm going to select the car door and select our top bevel. Of course, we copied the this corner bevel is copying this value. That's what so this is driving this. So now if we paste in here, this is driving this, which is driving this. It's probably better if you're doing something like this with a world driver controller to, instead of having things driven by something else which is driving something else and so on, is if we delete this driver and paste driver again, these two are separate, but they're both now being controlled by this. As you can see there. And we're able to set up every single object we make with this car to copy this offset property. And it's a really clean way of dealing with it. And that's how you would deal with something like car doors. The additional case I mentioned before is if we have a solidify and we're wanting to make it a fully solid object like that. So far we're only beveling this outside edge. Our inside edge is not being beveled. We have to make a special case for this to be beveled on the inside. And this is not as clean as just dealing with this. This is really nice and easy. To deal with the full solidify without only rim turned on is a little bit more complicated. It's the same principles though. The first thing I'm going to do is rename this vertex weight mix. I'm just going to call this one mix shell minus rim. I think it was shell minus rim. Rim minus shell. And what I'm going to do is press this copy button. And it just duplicates the modifier. And I'm going to call this one mix non-map minus shell. It might not be shell, I can't remember. We'll have a look in a second. So that's what our shell looks like. That's what our rim looks like. Yeah. So what I'm going to do is I'm just going to hide all our modifiers. These buttons up here are a add-on, really simple, called modifier tools. Just gives you these 4 buttons here, enables you to toggle all your modifiers on and off really quickly. It's well worth your time just going into add-ons and turning it on, because because when you've got a lot of modifiers, going through and turning them all on and off, it's a pain. So what I'm going to do is select all our non-manifold edges, just the outside edge. The quick way of doing this is to go to the top, press select, all by trait, non-manifold. And now I'm just going to create a vertex group called non-manifold. Press assign. So now when we look at this, that's what that looks like. If we turn on our modifiers, we're able to see this is what our non-manifold vertex group looks like. So if we take that one and subtract the rim, we're just going to be left with this edge. So instead of being shell, that's a rim. So I'm just going to change that to be non-manifold and rim. Let's look at our non-manifold group. I was right first time. Sorry. That should be shell. It was rim. I was looking at the wrong vertex group. I was looking at corners. It is non-manifold minus rim. And we've got that edge. So like before, I'm just gonna copy this modifier, our bevel modifier. This is going to be beveled inside edge. I'm going to set it to be non-manifold, and I'm just going to paste the driver back in again. So there we go. That's now beveling the inside as well as the outside. We've got a nice sharp edge on the inside, and this is fully non-destructive. So I'm still able to go into edit mode, adjust the shape of our bodywork, and we can see I've got shrink wrap turned on still, but we can see that I'm able to move these around, and our thickness and our edge is staying consistent, and it's working quite nicely. As well as the bevel offset, I'm just going to add a car panel thickness custom property in our driver controller empty. I'm just going to copy as new driver, put this to be 0.1. And our solidify, I'm just going to paste it there. So the idea is I am controlling all the objects, and there'll be many on a car, all the modifier sizes, thicknesses, offsets with one object, so it's consistent and we're able to deal with it really quickly. There's a couple of things to know just to finalise this workflow. When you have a mirror, you need to be careful with selecting non-manifold edges in this non-manifold group. The reason for that is it will bevel along the mirror. So if we put our modifiers on this edge, we will see the two cases. So there's this mirror edge, and there's another case I'll explain now, where you need to account for. So to copy modifiers from one place to another, really simple. You select the object you want to put the modifiers on, and then you select the object with all the modifiers on last. It makes it the active selection. You see the highlights a different colour. And all you do is press tab and type in link. And we go down to here where it says link data. We press it. It looks a mess. Don't panic. We just need to change our link data type to be, instead of object data, which is the mesh, we need to change it to be modifiers. And there we go. And this looks a mess. And there's a few reasons for that. First one is we don't have the shrink wrap. We don't have the vertex groups. See, they're highlighted red. So let's add the add the 4 groups we need. So there is corner, there is non-manifold, there is shell, and there is rim. It's really useful to keep all your naming conventions the same across everything, because you're able to copy and link stuff, and you just write in the vertex group names. So if we select the corners we want to be beveled, select them, and do the same with the non-manifold. Select all by trait non-manifold, press assign. We'll see it still looks a mess, even though we've done everything right. The reason for that is really simple, and it's a limitation of vertex groups. Because vertex groups, like their name suggests, only works on the vertices, it means that if this vertice has a weight of 1, and this vertice has a weight of 1, we want this edge to be beveled, and we want this edge to be beveled. These vertices are connected, which means this edge has a weight of 1 as well. And we can see that when we look in our weight painting group and we press on corner, we see this edge is fully red, even though only these 2 vertices are selected. Same with shell and rim. Rim shouldn't have this top be fully red. We can see that on this one. Rim only selects the outside edge. But because our mesh here has no separation from this side to this side, all these interior edges are being beveled. The fix to this is to add an edge loop. And that's all it is. And when we do that, we need to fix our non-manifold groups. We see if we press select, it selects the group and everything's selected. I'm just going to select all and press remove. Do the same process again, select all by trait non-manifold, press assign. And now that's working correctly. Same with corner. I'm just going to remove it, select these 2 edges, give them a bevel. I've misspelled corners. Corners. There we go. There we go. Go through and check all your vertex groups aren't highlighted in red. Otherwise they just simply won't work properly. So make sure you check that. So this is looking okay. The only problem we have here is this edge here, and that's because we're using a mirror modifier. And if we select our non-manifold, we can see this edge is being given the non-manifold group, which is technically correct because this is what our mesh really looks like. It's technically non-manifold, but we don't want that for our mirror edge. So we just select this vertex here. That's the edge which we don't want. Press remove. So now when we look at it, our non-manifold group is working properly, and if we turn on our vertex group, we're getting a really nice shape. It's being dealt with correctly, and we're able to keep on working. It's important to know that when you're working with this workflow, extruding copies your vertex groups. So if you're wanting to have a solid edge, it is genuinely better to hide everything, get everything as close as possible, and then go through and add in your non-manifold and corner pieces. Because at the moment, me extruding that has extended our non-manifold group, which we don't want. If we're not dealing with the inside edge, it's better. We can just turn off the bevel we don't need anymore, and we only need to adjust for corners. So it's not a fully non-destructive workflow, but it's as close as you can get in Blender, working in a robust way. Of course, you could just, instead of using these bevels, you use the angle. And work that way. But then you run into the limitations I discussed here, where you've got areas that aren't to do with the thickness, which are being beveled. So it's about control. If you don't need to do all this for the entirety of your car, don't worry about it. But if you've got an area which is really sharp, and some cars have them, where you've just got a sharp point which isn't beveled, then you need to think about using this robust method. So that's about it. That's how I deal with this whole workflow, from the shrink wrap to the car itself. It's important to know when you're shrink wrapping, by the way, the higher your subdivision, the closer your shrink wrap will respond. So go as high as is reasonable. At the moment, 3 is the subdivision level before where we start jumping up to number of faces which are unnecessary. And just keep it hidden. You don't need to deal with it most of the time. So yeah, that's about it for this sort of hard surface modifier workflow.